Hello, and welcome to GLISA's video tutorial introducing Michigan's Coastlines Through Time interactive tool. The Coastlines Through Time tool provides a look at historical shorelines and coastal bluffs around the state of Michigan, with an emphasis on locating critical bluff erosion areas and assessing potential shoreline modifications using historical aerial imagery. This tool was developed at the Great Lakes Research Center and Michigan Technological University in 2021. This video is meant to provide additional guidance for potential end users in the Great Lakes region, to help them navigate and better understand the Coastlines Through Time tool and its applications. In this video, I'll first walk through the tool and highlight key features and outputs that will be helpful for Michigan's coastal communities in assessing historic shoreline changes and areas at risk for future erosion. Then I'll provide an example demonstration of how this tool can be applied. Now I'm going to transition to opening the tool and briefly explain how to navigate its key functions. I'll navigate to the tool's home page using the link shown here, which can also be found in the video description. On the home page, we'll first see two interactive coastal viewers for the state of Michigan, one for Lake Michigan and Lake Huron shorelines, and the other for Lake Superior shorelines. The only difference between these two viewers is the default location it will center on the map. All of the data is the same and available for both peninsulas. On this landing page, you'll also see a 6-part Building Coastal Resilience video series, which was made in partnership with this interactive map project. And you can access the data that was used in these maps as well. To get started in the tool itself, I'm going to click the Lake Michigan Lake Huron map, which will automatically center the map over the lower peninsula. Once the tool opens, you'll get this pop-up, which is explaining what the tool is, the sponsors and partners, and also some information about the layers that you'll be able to toggle through. You can choose to not see this again upon opening or just select OK. This will always be the default view upon opening the tool, and data will already be selected by default as well. This sidebar on the left of the screen provides some information about the tool, but we'll minimize it in order to see more of the map area for our demonstration. I first want to talk about the static buttons, which are buttons that are available at any location that you navigate to in the map. You'll see these on the upper left and upper right-hand corner of the tool. Starting with the upper left-hand, let's review. There is a zoom in and zoom out button. You can use your mouse also to scroll, which I'm doing right now, hovering over a location, scrolling in and scrolling out. You can also click and drag. This home button can be used to send you back to the default extent, which is the map view you see when opening the tool. You can use this search function if you have a building, a city, or area of interest you'd like to jump to. The measurement tool can be used to measure the distance between features on the map. You have access to different measurement units here. You can add a bookmark to save a location you'll be looking at frequently. And the print button allows you to download the view of the map area you're looking at. Additionally, we have this upper right-hand corner. The layer list is going to open as default, so we'll start here. These are all the layers you have access to explore. We can tell the active data because it has a blue check mark. I'll review these in more detail during our example demonstration. This is the legend icon, which shows you the symbology of anything that you have active in your layers list. You'll use this tab with the 4 squares to change the base map layer to a given year, visualizing what that area looked like during that time. Lastly, we have an information tab that shows you the information that was on that pop-up disclaimer when you initially opened the map. Okay, so let's go back to the original extent and review the available data layers. I'll unselect everything and start from the top. Each layer has a drop-down button to view the symbol of the layer that will be shown on the map. The first layers are the coastal oblique photos for 2015 and 2012. So when we activate the layers by checking the box, we see on the map a white airplane. You can click on the plane symbol to see an image of the location in either 2015 or 2012. Next, there is a short and long-term rate of change layer, which will be overlapped if you turn these on at the same time. Short-term rate of change shows the rate of change in meters per year from 2009 to 2020. And long-term rate of change in meters per year from 1938 through 2020. You'll see the rate that each color represents, from high to low change, using the drop-down again. 30-year bluff retreat risk area uses previous change patterns to calculate projected future change that may occur in the next 30 years and is visualized by red lines. Next are the coastline bluff and water lines for several years to visualize how these features have changed, if at all. Here's a tip. Each coastline layer has the same line colors for water level in blue and bluff in orange, so adding too many to the map can be hard to interpret. The last two layers, Humphreys and Glaff, are shoreline classification layers. Humphreys tells us erosion intensity, and Glaff visualizes what the shore looks like at a given location, meaning if it's a beach or a rocky cliff area, for example. Next, I'll move into a demonstration. I'm going to use a hypothetical case example for a coastal residential area that is experiencing some coastline bluff erosion. First, I'm going to turn off all of the layers. This is so that I can get a clear map view before I start my assessment. Then, I'll use the search tool to navigate to Douglas, Michigan. I want to look closely, so I'm going to use the zoom function to move to a specific road near the bluff. This is where I want to bookmark my location so that I can come back to this point if I need to do further assessment. The local community may be interested in understanding the risk of erosion and the potential for roads becoming damaged or unsafe. And now that we're familiar with the layers, we're going to review and select layers that will help answer how much has the bluff changed in the last 10 years and how much land is at risk of future erosion. Answering these questions will help the local community understand the risk of erosion and the chance for roads becoming damaged or unsafe. Starting with our oblique layers, I'm going to check if I can see any visual changes to the shoreline or bluff from 2012 to 2015. I can see that the two images were taken from different angles by selecting the icons. I can also clearly see that the coastline and the edge of the bluff is most clear with the 2012 photos. Next, I'll use the short and long-term change layers to see if there has been significant change recently or throughout a longer period of time. These values are displayed far off the coast, so I'm going to need to zoom out to see them. I can note here that it looks like significant erosion has occurred in the last decade or so compared to over the last 85 years. I can interpret this by looking at the colored legend for each of these layers and compare. Moving on to the predicted bluff risk, I do see from the evident red lines that this area is expected to continue to experience erosion. This is something we may want to measure moving forward to note for sharing out with the community. I also want to review more specifically where the bluff and shoreline has been located in the past. This will further visualize the change being expressed by the other layers. It seems especially helpful to look at the 2016 and 2020 layers to see the 4-year change. Selecting both of these layers helps me visualize the change on the map at the same time. I'm going to take this moment to measure the distance and note the visual change as well as the more distinct area lost during this period of time. Lastly, I'll look at the Humphreys erosion categories and shoreline type. I want to make sure that the symbology is visible so that I can see that, again, there has been moderate to high rates of erosion at this site based on the color shade. I can also tell through the symbology legend that the shoreline is mainly sand beach. To answer my questions, I now know that I want to use the 2020 and the 2016 coastlines layer to see how much change has occurred in the last 10 years, given the data available to use. I'll also add the 30-year bluff risk layer. Visually, it looks like the road will be impacted by erosion in the next 30 years. I can measure the projected change as well by using the measurement tool. Lastly, I'll add the Humphreys erosion type to further signify a high rate of erosion occurring at the site. So now I have some data to share that shows the erosion risk in this area. I'll then utilize the print tool to title and download the PDF, or I could select another option. To access, I can go back to the print tool and select my newly created file title. I see my map extent featuring the road and the layers on top, and it includes a legend to help me explain what is being visualized on this map. This concludes our demonstration video for this tool, which is great for observing coastline characteristics and changes through time. I hope this was a useful walkthrough that helped you better understand how to use Michigan coastlines through time. This video was created by GLISA, a climate adaptation partnership team funded by the National Oceanic and Atmospheric Administration, dedicated to helping the Great Lakes region build lasting and equitable climate resilience. This is one of several tutorial videos intended to help make climate, weather, and coastal resilience tools more accessible to end users in the Great Lakes region, under a project funded by Michigan Sea Grant. There are also accompanying guidance documents available for each of the tools covered in these tutorial videos, available at the link in this video description. The guidance document contains contact information if you have any questions about the tool. This video and accompanying guidance document were created for educational purposes only and are in no way affiliated with Michigan Coastlines Through Time or its developers.